For the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson. We are going to begin Unit 3 today, which is all about chemical bonding and intermolecular forces. In this unit, we will learn about the formation of different types of bonds, as well as the general properties of substances that contain these types of bonds. We will learn how to draw electron dot structures for simple ionic and covalent compounds, and we will discuss the origin of polarity within molecules. We will discuss the formation and nature of intermolecular forces, as well as their importance in plant and animal life. In today's lesson, we will begin by defining chemical bonding. We will also explain why atoms form chemical bonds. Students, if you are ready, then we will get started. A chemical bond is the attractive force that binds atoms together in a molecule or a crystal lattice. Most elements are not found free in nature. Students, please discuss the following question with your classmates. Why do atoms combine to form compounds?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I wonder what answers you thought of during your discussion. In the free state, most elements are quite unstable. Therefore, they often combine with one another to form molecules or compounds. By doing this, the atoms achieve a much more stable electronic arrangement. Gilbert Newton Lewis came to this conclusion first in 1916. He introduced his theory on the shared electron pair chemical bond in a paper that was published in the Journal of the American Chemical Society. In honor of his contribution, the electron dot structures that are used to display the chemical structure of atoms are sometimes referred to as Lewis structures. Atoms are independent particles that have relatively high potential energy, which explains their lack of stability. Nature prefers arrangements of these particles in which the potential energy is reduced. As we discussed, when atoms form bonds with one another, the potential energy is minimized. This results in a more stable arrangement of matter. When atoms form chemical bonds, they connect only by their outer regions. When this occurs, their outermost shell configurations become stabilized. Thus, when we are discussing chemical bonding, we are only concerned with the valence electrons of atoms. I am sure you recall that valence electrons are the electrons that exist in the outermost shell of an atom. Students, have a look at this table. Please fill in the valence shell electron configuration and the number of valence electrons for atoms of each of these elements. Then, describe the trend that you see.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I wonder if you noticed any trends in the table. Here you can see the valence shell electron configuration and the number of valence electrons for atoms of each of these elements. Perhaps you noticed that all of these elements are the 8A elements, or the noble gases. These elements have stable Ns2, Np6 outer shell electron configurations, or 8 electrons in their valence shell. Helium is the only exception, with a stable S2 outer shell configuration, or 2 valence electrons. Since the atoms of all of these elements are stable, they do not need to form compounds with other atoms. Therefore, valence electrons are responsible for the formation of chemical bonds. Atoms lose, gain, or share their electrons in order to attain the stable electron configuration of noble gases. This is also known as the octet rule. According to this rule, atoms tend to gain, lose, or share electrons until there are 8 electrons in their valence shell. The type or characteristic of the resulting arrangement depends largely on the type of chemical bonding that occurs between the atoms. Scientists have identified that there are different types of attractive forces that form the bonds between atoms, including ionic, covalent, and metallic bonds. The strength of forces depends upon the type of bond. For example, covalent bonds can be single, double, or triple bonds. You can try a fun activity to help you understand this concept. Grab 6 sticks that are about equal length and of the same thickness. Then, separate the sticks into piles, as you see here. Grab a single stick and attempt to break it in half. I am sure you will find that the stick is not very strong, and it breaks quite easily under force. Then, grab 2 of the sticks and try to break them at the same time, as you see here. You will find that they are more difficult to break than the single stick. Finally, grab 3 sticks together and try to break them. You will find that it is quite difficult. The strength of the 3 sticks can withstand more force than the strength of 1 stick. Students, you should try this sometime for yourself. In today's lesson, we were introduced to our new unit. We learned that chemical bonding is the attractive force that binds atoms together in a molecule, or a crystal lattice. We discussed that atoms bond in order to attain greater electronic stability. Atoms aim to have 8 valence electrons, so they can achieve the level of stability that noble gases have. This is known as the octet rule. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.